So good morning and good afternoon. In this video we are talking about how to improve sonic logs and evaluate using sonic logs to evaluate the pressure and porosity in reservoir monitoring for over change in 5 or 6 years. So we can use this app built in Python to Streamlight. We can import Streamlight as a CT. This is the code. We can import, in this case, the matplotlib. And we have the classic reservoir. We are in sandstone, siltstone reservoir with arcstone, sandstone. We have clastic and flute cast and groove cast. We have the presence of gas in some strait, and we have, in this case, we have this sidebar with constants. We are around this depth, around 800 meters depth. So the initial porosity is that. We are evaluating the initial porosity through the well testing in well bore. We have the initial pressure, and we have also the sidebar controls, and we simulate pressure and porosity change using this formula: initial porosity for 1 minus compaction rate for the numbers of years that we are counting. In this case we are counting for 5-6 years. And the pressure, the initial pressure is the pressure finally is initial pressure minus the depletion rate per years. We are the plotting, and we have this kind of application. You can see the change. The porosity is essentially constantly. We don't have an increase of porosity. But porosity remain also the same. We have a constant decrease of pressure that start from the initial pressure of the 24 kilopascal, and the porosity of 25s remain about the same, and the pressure in 5 years starts from this value around 32 and decrease to 24. So this is a situation in which the extraction of gas in a classic reservoir can produce, for example, other phenomena like subsidence, and we have a decompression of reservoir. So it's really interesting to study this case, because the decompression reservoir can be must be mitigated for the risk and the production. So we have to evaluate also the risk of the production. So the initial depth is that, the initial pressure is that, the compaction rate in this case is around the 0.3% per year, and so the pressure decline in this way. So the extraction of gas determines compaction and the subsidence in surface. You can use also, you can improve this app also loading a CSV file, or you can use also last file derivating from logs, from maintaining logs. And so in this case we can have the complete app starting from monitoring pressure and porosity from production logging, and you can upload here, for example, a file in CSV format. We have the basic processing, so the depth conversion, we estimate the porosity, we estimate also the zonal analysis, and we can make all in this kind I show you. So I show you a typical results and processing. I upload this file and you can try in your exercise. So yeah, show the table with depth and the various depth, pressure, temperature and flow rate. We can change the empirical exponential porosity estimation, for example for 2.4 or 2.5. And you have the pressure gradient porosity trends and the zonal analysis with the interproductivity zone start and end. So it's a typical analysis you can conduct using this app in Straight Line. Thanks for attention.